So, folks, the topic that Rahul asked me to speak about is building global innovation ecosystems. And it's what a great time to be participating in innovation across the length and breadth of our planet. I'm here from Southern California. It's about 8:33 p.m. on Friday evening. Many of you are in India, past 10 a.m. And I have also colleagues from East Asia and other parts of the world who are part of the Qualcomm ecosystem who have also dialed in today. So today I'll be dividing my talk into three parts. The first one would be about how intelligent computing is being enabled in all the devices that you use, you have in your pocket, in your purses, on your as eyewear, as glasses, the computers you use, the phones you use, the vehicles you drive, the robots you interact with. So that'll be the first part of the talk. The second one is the main theme, which is the innovation ecosystem that we see at Qualcomm that is emerging globally and that we are privileged to help incubate. And the last one is actually a very important part and the theme of Rahul's work, which is ensuring that in addition to technology and business growth, startups invest in building their own IP awareness and more importantly, generate IP to protect their hard work, protect their creative innovations. So with this, I'll take you back to Qualcomm's roots. This year, Qualcomm will actually be 40, and we were once a startup. In 1985, we started with satellite-based data services. In today's parlance, it would be called as Internet of Satellite, IOS. Back then, the internet wasn't there. What all we had was satellite-based communications, but we quickly applied ourselves to first 2G digital CDMA, then wideband CDMA 3G, then LTE-based 4G, and then continuing the OFDMA-based 5G. But as we continued the relentless pace of cellular development throughout the globe, one very interesting thing happened. When you invest in communications, communication has this gravitational pull of bringing computation towards it. So once that happened, you had devices like the first generation um, phones, such as let's say the Qualcomm PDQ or Blackberries. Remember those? Those are very popular as the first way to interact with the internet right from your phone. And then as more and more computing power, bringing in cameras, bringing in position location, bringing in multimedia processing happened, then modern operating systems started coming into the phones, and that gave birth to uh, the smartphone revolution. And combined with the smartphone revolution, streaming technologies and the app ecosystem also took off. And in the previous decade, we engaged and enjoyed a very rapid explosion of smartphone technologies across multiple fields, right? Whether it's AR, VR, or compute, or whether it's certainly modernizing the digital cockpit of the car. But in this decade, we find ourselves in a um, yet another quantum jump where the confluence of 5G combined with AI at the edge have come together, and this unique potency of 5G compute and AI is actually infused across all the devices that we touch and use. And that is the world that Qualcomm is looking to enable in this decade. So very recently, Samsung launched its Galaxy S25. These are some of the best AI capable, the fastest mobile phones that you can buy. Working with Microsoft, we redefined the PC experience with the help of Copilot Plus PCs. In fact, I'm giving this presentation from a Copilot PC. The Meta Ray-Ban has also redefined the way augmented reality is being used to interact with the world with eyewear. Similarly, wearables of every kind. Wearables do a lot more than tell the time or keep track of your steps. There's a lot that is happening. And in fact, both spatial computing, XR, and AI wearables are are co-evolving. Like this is a great way for the future body wear based electronics to evolve. Automotive, everything has changed from whether how connected your vehicle is, how your digital cockpit works, how your infotainment works in the vehicle, and suddenly autonomous driving, right? So you could see a market difference beyond the electrification of the transmission. Beyond that, you could see a market difference in the experience that we have today in cars versus, let's say, the engine based cars, right? And this is going to change, right? I mean, as cars communicate with each other, as vehicles communicate with each other on road, there will be an increase in safety, increase in autonomy, increasing in returning time back in your pockets versus navigating busy streets and dealing with heavy traffic, right? Similarly, on the edge networking side, the fastest Wi-Fi capabilities, Wi-Fi 7, for instance, are enabled through both edge networking as well as ultra-fast 5G Wi-Fi gateways. Industrial IoT is seeing renaissance right now, whether it's robotics, whether it's AGVs, whether it's drones, whether it's AI at the edge. And I'll speak about this in further examples. And the other aspect of edge AI computing is happening right at the network edge, right? Traditionally, AI is thought about as the domain of the cloud, and so certainly AI has been very prevalent in the cloud, but on the edge of the network, there is a lot of compute power that can be had, and that's what Qualcomm defines as edge computing. And then on the other side of the interface are all of these devices, right? So almost think of it as between the edge compute and all of these devices, they are just on either edge of the computing interface. So the goal that we have at our company is not just to come up with the chips for the best communication or the best compute or the best AI, but it's actually the complete package, best in class connectivity, doing very high performance computing at ultra low power because we are mobile born. We're able to bring this combination of high performance computing at low power to all of these devices, and now leading edge intelligence. And I'll give you examples in subsequent slides. So, as you can imagine, over 40 years investing in these three categories of technologies: connectivity, processing, and intelligence, Qualcomm has also, from the very get go, in fact, one of our oldest businesses is that of um, being able to license technology for others to use. And this picture that you see here is from our headquarters. When you walk in, you see a patent wall, which has the front page, the specification of many of Qualcomm's patents, and we have licensed them profusely. In fact, in the 5G era, we have 200 plus licensees worldwide. And if you look back between 5G, 4G, and older connectivity devices, a total of 18 billion devices in the planet have been licensed through Qualcomm's technologies, right? And also that in addition to such devices, we have over 250 million connected vehicle units, right, worldwide. So in addition to developing products, we also develop technology that we profusely share across the industry. And this is a very different business model than, let's say, our cousins up north in Northern California, who tend to have more vertical ecosystems. Qualcomm is as horizontal it can get. In fact, I tell people that it's remarkable that you cannot buy anything Qualcomm. Maybe you can buy a piece of garment like a cap or something that says Qualcomm. But other than that, Qualcomm is always inside. Qualcomm is always embedded, which means by definition, for Qualcomm to succeed, we have to succeed through the eyes of others, right? So this drives us to collaborate across the entire global ecosystem to drive innovation. In other words, only when you succeed with our technology, we taste success, right? Intrinsically, we don't have a product. We're not a B2C company, right? We are a B2B company in that sense. So, keeping with this theme of driving global innovation, in my team in particular, we work at the grassroots level, where innovation is just stirred up, and the birth has been given to innovation. So across the globe, from certainly here in the US to Africa to Saudi Arabia, a lot of work in India, then in mainland China, in Taiwan, in Vietnam, and also very recently in Japan, South Korea, and Singapore. we have invested in a series of global ecosystem development initiatives and programs, and these largely fall into the categories of supporting early stage high tech startups, providing lots of training. We have lots of IP courses that I will talk about. These are IP courses tailored to the laws of all the regions and countries that you see over here. And also we work with universities, right? So by working at the grassroots, we play the long game, meaning by definition, early stage startups are fragile. They are new, but if you give them an infusion of technology and this IP GAN, if you may, early enough in their life cycle, you actually improve the chances of them surviving past like the very critical fifth year, right? Every startup in the third to the fifth year is one of the most vulnerable periods, and we have seen time and time again that our startups almost get a 2-year boost through our incubation programs in the technology area, and they walk out with also a very good idea of how to protect their intellectual property. So as I was saying, Qualcomm drives, in particular, um, my team drives the ecosystem initiatives across the globe, and in particular, um, focusing on the startup incubation prong of our activities, we focus on um, a, a series of activities in our mentorship series, which I'll actually cover in the next stage. What I want to point out is that we are active in 6 countries and regions, and over the past 9 years, we have been able to incubate 262 early stage startups. And the pictures of recent programs are present on the left side. So going from the leftmost, we had the India startup finale last year, the Taiwan finale in November, the Vietnam finale in August last year, and also our activities in Africa for the African startups. In addition, I'm also very proud to mention that we are able to um, seek and attract startups that are led or founded by women. In fact, a quarter of our startups have women CXOs, and our startups are beginning to experience business success also in addition to technology and IP success. 12% of them are past Series A, B, 4% have exited. They have raised a lot of capital. They're shipping in commercial volumes. And on the IPR side, a stat that we're very proud of, close to 1,100 patents have been filed by several of these 262 startups. And a bit later, I will talk about our investment in IP awareness training. We have over 16,000 students in the world who are taking various of our IP courses. So I wanted you to keep this picture in mind as to how we have worked with startups in India, in Taiwan, in Vietnam, in Africa, and then very shortly in further countries in Asia and also in Saudi Arabia. And the stage at which we collaborate with startups is typically post angel and pre series A, because this is the phase where startups are in the right stage of their development cycle where they can ingest a deep infusion of advanced technology. And also, this is the right time for them to be able to start to build their IP portfolio, right? So the pre-seed, seed, pre-A is typically where most of these 262 startups have been when they joined our program. So there's a method to this madness. We go through a rigorous selection process. As you can imagine, this is a deep tech incubation program. So we have to select startups who have the technical and business caliber. And once they join our program, we help them through rapid prototyping on Qualcomm platforms. Obviously, we provide lots of technical guidance from our engineering team that's based in the US, Taiwan, Vietnam, and India. And in other regions, we provide such technical guidance virtually. We also invest a lot in business and obviously intellectual property rights coaching. And then we bring them together in a finale. In the incubation program, we have prizes. And in the mentorship programs, we help the startups actually through marketing and broadening their reach through the Qualcomm networks. And once they graduate, they become part of our alumni family. And we have deep connections with many of our alumni as they continue on with their journey beyond our programs. Now, the 262 startups that we have incubated are represent actually 22 industries, and these 22 industries range from all the way from aerospace to voice and music. And if you're interested, you could scan this QR code for a directory, external directory of all our startups, and you can explore their products and services at this directory. Now, one thing I wanted to highlight is that increasingly since the last year, we are seeing a very fast growth of AI usage on these in the products and services by the startups. And as you can imagine, the reason for using AI on device is to actually have the immediacy of responsiveness, to be able to use high performance and very energy efficient hardware. Cloud-based AI is inherently very costly, both from a computation cost as well as a energy cost. So if inference can be run on edge devices, and if it can be run on billions of edge devices, that is certainly the vision that Qualcomm has, and that's what we are trying to realize through startups also. So in order to enable this inference at the edge ecosystem, Qualcomm is investing heavily in a series of tools in our toolkit, certainly hardware, software frameworks. They're orchestrators that help with bringing models, AI agents, RAGs into the mix. Tools such as AI Hub, which actually help provide a digital playground to be able to optimize models and run it actually on the cloud on target. So we have devices hanging off of the cloud that you can orchestrate and run. And then once you have optimized it, you can bring it onto a physical device. And we support a variety of operating systems for these edge devices. So with this very rich toolkit for enabling AI at the edge, here are some examples of startup use cases that use AI, and they fall into some of the fields that I mentioned earlier in smart cities, in healthcare, in smart industry. Also, there are some very domain and industry specific use cases. Certainly, a lot of work with building the modern tools for the edge AI ecosystem and also in education. And these use cases range from, let's say, robotic kits or embedded kits which run Ubuntu or Linux or Android on very powerful edge processors, or Linux on edge cloud processors. These are like mini processors that can fit into a PCIe chassis, or certainly AI Copilot PCs or Android phones or drones, right? So AI is running on variety of form factors using a variety of operating systems. Let me speak about three of these so you get a slightly better idea about how edge AI gets used up in use cases. So I have three use cases. On the left side, I have an example from India. A Chennai-based company called Aduvo Diagnostics uses AI in a smartphone type form factor to actually assess wounds. They can point their camera and look at wounds and provide the clinician a reading of the microbial activity in the wound, and hence the modalities of treatment right after. And this is based on one of Qualcomm's vision platforms. And they have been able to build a very successful diagnostic system, almost like a tricorder, if you remember such devices from Star Trek. So this is like the next generation of on-site clinical diagnostic tools, right? The next one, if you're hungry, is a automatic noodle making vending machine. So what this machine does is that in about 2.5 minutes, it can make you piping hot, steaming hot bowl of noodles, and it actually tastes very good. It has absolutely nothing to do with microwave noodles. It tastes really, really good. Where the AI piece comes in this vending machine is that they use a multi-AI agent architecture, which can use LLMs for interacting with the user in the language of your choice. Use LLMs to take your order, query the internal inventory system, provide logistics, right? So this startup is Yokai Express, and they actually won our contest in Taiwan last year. And if you certainly are in Taiwan, in Japan, or in the US, there are many locations where Yokai Expresses robot vending machines have been put in place. The third example I have for you today is from Vietnam, a company called VB. In fact, they are the winners of our Vietnam contest last year. They come from the conversational AI industry, where they use conversational AI that is not just only for Vietnamese conversations, but it's domain specific. So you can imagine that industries like banking and finance have a lot of jargon, a lot of lingo, a lot of uses that are very specific to that industry. So they have ported this conversational AI on a edge cloud box that is able to serve multiple client to customer agent conversations using this conversational AI platform. And then they are expanding this kind of domain specific conversational AI to other industries, right? So I hope this gives you an idea that there's a lot more to AI beyond, let's say, chatbots and generating, images and videos. AI is being put to real use by startups such as these. So with that, I'll move on to the third part of my talk, which is to highlight the IP work that is being done by startups. As I mentioned before, um, close to 1,100 patents have been filed by our startups. By the way, these are not patents that these patents belong to the startups. Qualcomm simply teaches them about patenting and enables them to file their patents. And during our program, they probably file one or two patents, and then after they graduate from our program, we observe how does the patenting activity continue, and you bet it does, right? In India, startups have filed over 500 patents, similar number in Taiwan. Vietnam is ever increasing, going past 1,100. And in Africa, actually, this number is slightly old. We already have 3 to 4 patents from our African startups. So very, very happy to see this activity in various parts of the world. In fact, everywhere where we have been able to incubate startups, we are able to encourage startups to also consider protecting their hard work. So I'll go through some slides real quick. Here are pictures of granted patents. On the left side, if you come to our Bangalore Innovation Lab, you'll actually see a patent wall, which is not Qualcomm's patents, but the patents of the startup. So this has become a favorite spot for many visitors to kind of see the good work of the startups in India. In fact, one of our startups, Wellnesses, they have started their own patent tree because they're beginning to build their own portfolio. A similar story is there in Vietnam. The Vietnamese startups are filing prolifically both in Vietnam, in the US Patent Office, the India Patent Office, and likewise in Taiwan also. The very, very active amount of work in Taiwan, in the US, in mainland China, Japan, and Europe. Now, beyond working with startups, Qualcomm has invested in creating a series of IP training courses. We started in Europe. Then in India, the course we have is known as L2ProIndia.com, Learn to Protect, L2ProIndia.com. In the US, we have the Inventors Patent Academy. In Africa, L2ProAfrica.com. In Taiwan, we have a course in Mandarin, which is L2ProTaiwan.com. And this year, we are investing in an Arabic language course that conforms to the laws of the Kingdom of Saudi Arabia, the IP laws of Kingdom of Saudi Arabia. So in each of these courses, we teach about patents, copyrights, trademarks, trade secrets, the various modalities of IP. And then we talk about the filing procedures in the specific. So in the Indian course, you'll obviously learn about Indian filing procedures. In the US, that at the USPTO, so on and so forth. And I have the QR codes over here if you're interested in a particular country's course. And by far, we have the most students in India, followed by the US and other regions. So 16,000 and more growing globally. And I hope in India we'll see much bigger numbers thanks to programs such as Turnip's Innovation Festival. So my final slide, wanted to give you some key takeaways from that perhaps you can consider from my slide. It's important for high-tech companies such as ours to engage in purposeful innovation. Like I said at the onset, we only succeed if others can realize their products and services through our technologies. So this pillar of empowering digital transformation is where all of this work belongs. And this is being fueled by 5G, literally as the wireless fiber, also the availability of low power, high performance computing everywhere, and as you have noticed, intelligence everywhere. AI at the edge makes a lot of sense from the perspective of avoiding the unbounded cloud costs to have the very high latency that services like voice or conversation require to save on energy, right? I think doing a cloud-based GPT application costs anywhere from 10 to 100 times the cost of a basic search, whereas on your phone is just your battery charge, right? So the energy savings are profound when you run AI at the edge, and certainly privacy and security of data. What we are seeing is now what I call as the Cambrian explosion of use cases. These are B2B use cases, in some cases B2C, but we are seeing the IoT world, the PC world, the mobile world exploding with on-device edge use cases. And these in turn are generating new compute and interface paradigms, right? So no longer it's a, someone moving a mouse or their finger to get something done. They're using very different kinds of UIs, very intelligent, intuitive UIs to actually interact with this digital world. And then the third prong is that if you have noticed, we really like the situation where um, startup founders, inventors solve their local problems in region, because we believe that inventors living in a region deeply understand the uniqueness of the problems they're solving, right? And then generally what happens that if let's say somebody solves a problem in Africa, it's equally applicable in India. If someone solves a problem in India, it's equally applicable in Vietnam and vice versa, right? So we also see this ability to infuse ideas and techniques that are born in a given region and take it to other places. And the way we enable this regional problem solving is to basically give access to state of the art compute. You don't have to wait for trickle down from larger economies or advanced economies, right? By providing 5G, AI, robotics, IoT right at the grassroots level, we actually infuse this cadre of new startups with the latest. They are no behind any other startup anywhere in the developed world, right? So this is what we have been able to engineer. And lastly, but not the least, making sure that IP protection goes hand in hand with technology and business development is something that we believed in, and now we are able to also make sure that this happens. Now, in this world of AI, I just wanted to end on this note: is that what we are saying is AI is actually augmenting human ingenuity, right? I mean, I know there are a lot of people who are worried about AI replacing work. Yes, AI will absolutely replace mundane, boring, repetitive work. That's in fact, otherwise, why even invest in AI? But what we are saying, and again, if you hark back to the three examples I gave you, what we are saying is that AI is becoming an accelerant, a catalyst for further ingenious ideas, right? So before I end, I just wanted to point out that there are QR codes over here for the early stage startup directory. Also, Qualcomm has a lot of training courses that are geared towards startups. You could also go to our ecosystem training page. And lastly, if you're interested, if you're based in India and you're interested in learning about IP, then please also check out our L2 Pro India course. So, so Rahul, over to you. That was those are the points I wanted to make.
Great. Thank you, Sudeepto. Really appreciate it. And yeah, I'll start with a question. Then maybe the audience can join in. So can you say a little bit what is edge AI? Like, how does it look? Is it something physical? Is it like the chips? Because, like, how does it work? This edge AI. So it's a bit basic question, but like, if I
Sure.
have to put it in my hand, like, how
Yeah.
does it look like?
So to answer that question, I'll say that at the highest level, there are two aspects to AI. There is the training piece of it, and then there is the application piece of it, right? Now, typically training of AI, where by learning patterns from data sets, you come up with a basically a pattern model, right? So a pattern model would be used to encode or encapsulate, let's say, a word pattern for text, or a audio pattern for voice, or a image pattern that might look like a cat or a dog, right? So that is the pattern that is encoded. Now, on the inference side, when you go and say that, hey, create the image of a cat, then the trained model, because of the encoded pattern, can generate that image of a cat, right? Or if you say that what comes after the word republic, then the model will be able to guess that, hey, if today is close to January 26th day, Republic Day, for instance, right? So when we talk about edge AI, we're saying, can we run that inference on devices that are in your pocket, as opposed to having to send a query from your pocket device over the cloud, over the
Hmm.
internet, wait for a cloud to respond, and then bring that response back? Can we just do it
Hmm.
directly on the device itself?
Wonderful, wonderful. So great. Let's see some questions from the audience. Codeweed has asked, let's see, Suipto, if it's relevant. Do you think Qualcomm will make their processor to 2 nanometer because it is 3 nanometer now? Is it, if it's relevant, we take it. Otherwise, we can take some other questions.
Yeah, we Qualcomm has always been at the forefront um, of the latest nodes, and if the future nodes go there, we'll certainly be among the first to adopt this.
Yeah, so Dr. Bala Gopi is asking, today's device is able to get interfaced with their current speed of operation. If not, how to improve it? Does Qualcomm design QD support? Uh, yeah, I mean, I don't particularly understand this question, sir, Bala sir. If you can please rephrase it, that would be great. So I could ask, something like, suppose there's a Indian in academia, there is some student or some professor who's working on certain designs related to 5G, IoT, and so what they can do to get Qualcomm's attention and join the startup system.
In fact, let me use a particular file to explain that. Um, we have several programs in India that we have launched almost every year since 2016. One particular program, to your question, Rahul, I would draw to is the Department of Telecom's 100 5G Use Case Lab program. This is an excellent program where the Department of Telecom has given 100 universities
Mhm,
money and to buy equipment for 5G use cases, right? So I would
mhm.
encourage, in fact, my colleague Pushkar Apte, who leads our India team, he is interfaced with DOT as well as many of these use case labs. I would certainly ask you to contact him or through DOT and kind of join this program, the 100 use case program.
Great, great. So yeah, a lot of comments on YouTube thanking Dipankar Saha. Thank you. Uh, okay, one question is there. Anand Gemini. He says, "How is AI more easily capture over all software developers?" So I think he's talking about use cases in software development. So uh, my question is how AI is more easily capturable all over software developer.
Yeah, so if I interpret the question accurately, um, so if you think about the basic act of code generation, right? I don't know of any modern programmer who doesn't use AI already to generate code, right? And this trend started 2 years ago, and I would be very surprised if um, 50-60% of software developers already don't use AI, right? And so this is on the code generation piece of it, right? Because in many cases, AI can actually write good quality code, and AI can write code for better memory efficiency, better processing, better encoding, better reusability to check for reentrancy, so on and so forth, right? But the human is always in control, right? I mean, nobody is going to hold AI responsible if there is a failure in the code. They're going to hold the human manager in charge, right? So the humans are always responsible in studying the code, in understanding the code, in testing the code, in making the code maintainable, version it, right? So that is one aspect of AI, right? I mean, there are others who have proclaimed rather boldly that AI means the death of software coding. It could be far from true, right? Qualcomm is not only a chip company, we're one of the largest software companies in the world. No AI has replaced our software developers, right? So it's not a question of replacement. It's a question of can AI be used to write better quality, more conforming code, right? So that's one aspect of it. The other aspect of AI is that AI is extremely good at detecting patterns from large data sets, right? So AI can be used as an agent by software to extract those patterns and then take further actions, right? So the way AI is changing the software paradigm is that it's a very powerful tool that that can take action on it has agency. It can take action on itself, right? By itself. So one part of software is to steer and guide the AI. The other part of AI self-generates responses and self-generates output. Then it comes back to the software for presentation and for interaction, right? So a short way to summarize what I just say is that now we are in a very different form of evolution where software and AI are co-evolving, right? So
Hmm.
one not one simple way to say what I say right now is that um, if 30 years ago you started programming on a PC and for the first time we had software on the edge device on a PC versus on the mainframe. Right now, that paradigm is software, right? So we went from PCs to the paradigm of SaaS to the paradigm of mobile compute software, right? Now we're in the paradigm of
Yeah.
AI based software.
Wonderful, wonderful. So one question I have, since this also relates to the topic, about innovation, collaboration globally. So one thing that I feel that inhibits collaboration and innovation globally is this risk, because there's this thing that we should not use chips made in China because there are some security risks. So how does Qualcomm address it? Because eventually we are buying chips probably designed in US, or I think maybe manufactured in India, but designed in US. So is this a realistic trust issue that governments have about using chips, designed by some other country?
It is the real concern, right? We hear it from governments and customers all over the world. We also work very closely with many customers in China. In India, you have beautiful Qualcomm-based phones from Xiaomi, OnePlus, Oppo, Vivo. Motorola is owned by Lenovo, right? So inherently, we find ourselves in a position where we work with practically every government, engineering ecosystem in the world, right? Whether it's in Africa or in China or in the US or Europe, right? So some of the guidelines as to what what a given country can consider as safe for consumption by their country, right? By the way, it will differ, right? I mean, if you ask the Chinese, they'll have a very different viewpoint about what they consider safe, right? So it is very much a personal question. Like, I mean, the way I would ask you is that um, which strangers will you allow in your home, right? Maybe the UPS driver, delivery person, right? But perhaps not somebody else. So it does become a personal something that you have to assess for yourself. But some of the tools that I would use is do the chips have inherent security such as trust zones, such as immutable hardware? Do the software come authenticated by somebody who is in your country? If that person is errant, then you can take them to and prosecute them under your country's laws. The third question I would ask is the software that you're putting in your devices, is that entity around for security updates, for feature updates? Is that entity around 5 years from now? Let's say I put a IoT device in a smart meter, and the vendor is gone 5 years from now, and I need to upgrade it. Is that person around in my country? What happens to my data? What happens to the insights of my data? What happens to AI models that are developed in my country, right? So I think these are all the questions at various levels that each country has to answer for itself, right? And being a global company, we conform to the laws of every country that we operate in, right? Because that's the only way you can do global business. And when someone raises a security question, we try to address it from an engineering and business point of view, right? So the answer is, in
Yeah.
short, it's complicated, but there is a method to the madness.
Yeah. Great, Sudipto. Thank you so much for your views, for something quite amazing, quite something quite at the cutting edge of innovation where we are in the times that we are living, and really grateful to have Qualcomm and something like as cutting edge as Edge AI, and also many questions are there in the chat which we could not take. How Qualcomm supports student innovations and startups academic incubator. I think Swipta has already answered that. There's obviously the L2 Pro platform. There are many Qualcomm India Design Challenge and many other ways in which you can collaborate. If we have some links, there are some links in the description, so please check them out. There are some contacts there with which you can get the attention of Qualcomm. And so yeah, Suipto, thank you. Really
Thank you.
appreciate having you. And yeah, any last words if you have would be really nice.
No, this is actually a great time to be a entrepreneur, right? The world is moving very fast. Technologies are converging. So in fact, the converging technologies are accelerating each other, right? So if you think of each of these technologies as sort of exponential curves, right? Imagine how the exponential curves are being modulated by the next curve's exponent, right? That's the pace at which is why in 24 hours, practically a lot happens in the field of AI. Similarly, a lot is happening in IoT, right? Now, don't be disheartened by this space. You might feel like, hey, I'm being left behind. Do something. Join at any point, right? Grab this opportunity now, because you just have to start somewhere on the curve, right? Some One great insight that I give to my daughter is that whenever you look at an exponential curve, no matter where you are at on the curve, you are part of that exponent. One part will
Yeah,
look very steep and one part will look very shallow. No matter where you are at, you're always on the exponent. So I'll end,
yeah.
end on that.